So good evening, guys. So, friends, yesterday, like we missed two sessions. Right? Missed two sessions means we took the session, but the recording somehow, unfortunately, it didn't happen. Right? So session 3 and session 4, both the recordings we had covered a lot, but unfortunately, the recording was not done, and we will be getting into the fifth session today. Right? So now, but what I would do, right? The third session and the fourth session, I will do re-recording myself, and I'll give you that recording to you guys. Okay. Hmm? So that's how we'll do. And most of other people, right, who are part of the channel, right, they had asked me, they messaged me and asked me about the third and the fourth video also. But unfortunately, as I mentioned to them the same, that we couldn't record it. I mean, we couldn't record means the recording didn't happen. So that's the reason it was really unfortunate that we were not able to give them actually. So that is one of the reason that I will do a re-recording for both the session. Okay. So now in today's agenda, what we're going to cover. See, yesterday night we had covered up to file system, right? The file system. So though like the session was not that much conclusive, because that in a very we had a multiple breaks, right, in between when I was taking the recording or when I was taking the class, right? So like we couldn't really conclude it very nicely. But what I will do in my recording, right, I will mention each and every directory separately in very in detail manner, so that you will get to know about how this file system works, right? So this is the inverted tree structure file system, we say, and this is the same file system which is used in Linux as well as in Unix operating system also. Okay, so from now onwards, I will not use any word known as a Unix. I'll always try to use the word Linux itself, because Linux is the one which is used now, not Unix. Okay, so but still, wherever the context comes, wherever I feel like I need to use the word Unix, I will use it. Okay, so now, so this is what we had concluded yesterday, and if you remember very clearly, like we had executed some command known as a dmessage command, right? Dmessage command will give you the system, like it will give you the system, what do you call, it will give you the system or the kernel information, right? What, so whenever the kernel is generating, because kernel is keep running, right, in the in the kernel mode, right? So this kernel will be keep running in the kernel mode, right? Kernel will be keep running the kernel mode, and kernel also generates some logs actually, and those logs you can watch from the user space itself. So how you can watch from the user space? By executing a command, dmessage command, like this. Or else you can do a cat of /var /log/messages. Okay, so this is what we have seen it actually. Okay, so now I think this has been closed. Okay, this session. Okay, so that's how we had concluded yesterday, and we had we have even see that how exactly the bash process or the bash shell will get created. So this again I will repeat it in my recording session, need not to worry as of now. Okay, so what we are going to do today. So what is our session 5 agenda? Day 5 agenda, Linux Day 5 agenda. So we will try to continue with the shell itself. Hello, yes, guys. Uh, yeah, let me know please if you have any doubts. Okay. So what we are going to do today, that we are going to continue with the shell itself. Okay. Well, what is the feature of the shells? What are the features of the shells? We already discussed about a login and a non-login shell, but anyhow, I will make it in a recording, re-recording again. So what are the features of the shell? Okay. Shell variables. Okay, as well as we will get into some commands. Okay, this is what today's agenda. We have to quickly cover up all these things. Okay, now, okay, I'll do one thing to make it this session alive. I'll just continuously run this process. Yes, guys, friends, tell me if anyone else has anything. Please let me know. Okay, now, so what is a shell? We already discussed about this. Shell is nothing but it is the interface between a user and the kernel, right? So this is a user, this is a kernel, or kernel or nothing but operating system, right? He's a user. You can call it user space or user, right? And here there's the kernel, or you can call it as an operating system. In between in the user and the kernel, there is something, a small thin layer, we call it as a shell. If somebody asks me the question, where exactly the shell comes, whether the shell comes in the user space or in the kernel space, basically the shell also comes in a user space itself, right? It comes in a user space itself, right? So this is a user space, and this is the kernel space. You know, right, yesterday in couple of classes back, I said that always kernel will be running in a kernel space, and the user space, all the users will log in user space, and your root file system will always be there in user space, correct? In yesterday night, we discussed the root file system, RFS we call, root file system, will be there in a user space. It means that actually whenever a user is actually logged in, he'll be logging into the root file system itself, actually, correct? So with the help of a root file system, he will do any kind of an operation onto a file or a directory. See, whenever a user logs in, like here the root user has logged in, correct? Now root user has logged in. He has to do some operation, right? He has to navigate to some path. He want to do some operation. So he has a full fledged. So he can go to the etc cd and enter and say LSC. He can do many operations. Why? How he can do many operation, or what is it? How he can do it? Because right, he is actually sitting onto the file system itself. He's working in the root file system itself. That's how he's able to navigate, right? So root user has logged in. Where root user has logged in? Under the slash root, right? So that's what we had discussed yesterday. Here, under the slash root, here the root user is sitting and he is navigating to any of this path of the file system. So he can do any operation, right? Obviously, he can even execute the command also. Here, assume that the user is a root user, right? He can execute any command, he can open any file, right? He is doing all kind of an operation sitting in a user space. And how he does an operation sitting in user space? With the help of a shell. So here I have drawn the shell, big shell, but actually the shell will be attached to him like this, like this. So this is a bash shell. So it means that he's sitting on top of the bash shell and he's actually executing all the commands. He's doing all operation onto the file system, right, guys? So now, so sitting a root user, what, so as I said, right, the shell is, but it is an interface between a user and the kernel. Whenever a user want to interact or it want to communicate with the kernel, it cannot directly communicate with it. There has to be an interface. By using that interface only, the user can communicate with the kernel. And that is why with the help of a shell. Without a shell, a user cannot communicate with the kernel, right? Now, what are the different ways a user can communicate with the kernel? As I told you the last session, right? Right? He can communicate with the kernel with the help of a commands. He can communicate with the kernel with the help of a system calls, or we call it as an API, application programming interface. He can communicate with the kernel with the help of signals. These are the different modes where the user can actually communicate with the kernel. These are the only 5 ways, different ways where a user can actually communicate with the kernel, right? Now, for example, this root user, right? He is executing the ls command. He is executing the ls command. He is executing the ls command. What ls command will do in Linux? Ls command is going to list out all the files and directories in the present working directory. Suppose you see here, if I execute the ls command, see, it will list out all the files and directories in the present working directory. Correct, guys? So ls command is being executed. You can execute. See, if I say ls, you could see that it is showing me some two files, original.ks-cfg, anaconda-ks. These are the two files it is showing you. Even if you execute the dir command, this command is used in Windows. Even this command will also show you all the files and directories. So this command is a Windows-based command, but still it works in Linux also. Okay. So here, so what the user is doing actually, a root user, he's actually sitting on to the shell and is executing a command, no ls command. And that command is being executed. And you know that, as I told you, that most of the commands, to check where that command is, from where the command is coming from, you say which ls. Can you see? Which is an alias, or else you can say where is ls. So it says that slash usr bin ls. So this is the path where the ls command is placed. Now, what shell will do? Now, suppose somebody asks you in interview question, okay, whenever you are executing any command, suppose root user is executing the command, ls command. Can you tell me in the background what are the things which will happen? How this command is being executed? Can you tell? They will ask you. So what you have to say, sir, whenever a user, suppose a root user, he is executing ls command, okay, what the shell will do, bash shell will do, bash shell will check the from the path n1 variable, it will check whether the ls command, where exactly the ls command is placed. So with the help of a path environment variable, we have not come to the variable yet, we will come into it later on. So just I'm saying that with help of a path n1 variable, the shell will check where the command is coming from. So how to check the path and variable? You have to say echo space dollar path. This is one of the shell variable. You remember, like in one of the shell variable which we executed yesterday was capital echo dollar capital shell. If you execute this command, it will show you on which shell you are working under, right? So this is one of the variable of the shell. We will discuss all these things later. Similarly, there's one more variable which is echo dollar path. When I execute, it will give you a path information about the commands. Now, if I when I executed where is ls, you could see that it is showing me the path of the ls command, sir. It is there under slash or bin directory. Okay, what the shell will do, what the bash shell will do, whenever I execute any command, ls command, with the help of this path environment variable, the shell will search whether the ls command is there in the usr local s bin. No. Usr local bin. Yes. Here is the path where the ls command is there. Can we go to this path, guys? Slash usr bin, sorry, local, and say bin. And if I say ls, oh, there is no ls command. Why is it not there? Oh, ls is an alias actually. It's an alias, but okay, where? So if I go to the bin directory, actually ls command is there here, sir. Actually, here the ls command is there. So actually, you'll try to load from here only. ls command. Where is ls command? Where is ls command? ls. It will be top only, I think. lsfnl here somewhere. ls command will be there. So basically, ls command is in the bin directory, sir, not slash usr bin directory, or else the slash usr bin directory might be a soft link to the bin directory. Okay, so here the bin directory. So basically, what is happening that ls command is there under the path slash bin, under slash bin. It has an ls command over here. Now, what happened, right? What exactly it happens that actually, whenever you are executing the command ls, the shell will search for the ls command in this path and one variable. So whether the command uh, local bin. Let me check, sir. 1 second, sir. Root bin. How come root bin is coming? Strange. Not sure how this is added. This is a Red Hat 7, right? So maybe there is some changes is there actually. Okay. Yours are look. Yours are. Uh, hold a second. Hold a second. Which ls? Okay. In the environment path slash usr bin ls. Okay. So slash usr bin. Yeah, sorry, sir, guys. I'm sorry, I mistakenly added. It is then the slash usr bin actually, not s bin. Sorry. Okay. So I'll say that under slash usr under bin here you have an ls command. I'm sorry, guys. So what will happen that here in this case? So coming back to here, whenever you execute the ls command, with the help of a path n1 variable, the shell will search where exactly the ls command is coming from. So whether the ls command is coming from the slash usr has been no, slash usr local bin no, slash usr has been no, slash usr bin yes. So this is the path where the ls command is coming from. So what the shell will do, shell will directly go to this path, load that ls command and execute it. So it will try to load that command here. Here what will do, it will try to, the shell will try to get into this path usr local has been, load this ls command. It will try to load it in sense what will happen, right? Load it in sense what exactly happens that this is the main bash shell, sir. This is the main bash shell. Now what happened that, let me rub this. Okay. Now, how it happens is it will load this ls command. So loading in means what means what the bash shell will do basically, guys. Bash shell is a main shell actually. What it will do, it will create one subshell. It will create one subshell. Subshell means that what? It's bash shell's child shell. So bash will create one child shell actually, or it will create one child process. This we call it as a child process, or we call it as a child shell. Create a child shell. Now what happened that as soon as the bash shell is trying to execute any command, it will not execute by itself. It will create one child shell or it will create one subshell. How it will internally create? Because there is a bash shell, it will use one system call, the fork system call, like this. So with the help of a fork system call, what will happen that the main bash shell will create one child shell. Okay, fine. After that, one more system call it is going to create. It is going to use that system call is that what exec system call. EXEC, exec system call. So exec system call is being used. Fork system call it will use us to create a child process. Exec system call will be used to load that ls command. So it will say that now, okay, fine, this ls command is there, the slashes are bin. So what the main bash shell will do, right? It will try to load this command, ls command into this child shell. So it will tell to the child shell that you please go to the slashes or bin. There you try to execute this ls command. So what happened now? This child shell or the subshell, it will execute this ls command on behalf of this main shell. So once it completes a task, once it executes the task, it means that once it executes this command, so what happened that it returns back to the shell, it returns to the main parent shell like this. It will return to the main parent shell, and it will tell that okay, take this output of ls command. Now this bash command to the user, it will show the output. So when I execute the ls command here, see it is showing me the output, but it is not the bash shell who's doing actually. It is the child shell who is doing. It means that for every execution, always the bash shell will create a subshell. How it will create a subshell? It will create a subshell with the help of work system call, and it will try to load that information about what you need to do, right? So it says that actually the main bash shell will tell to the child shell that you please execute this ls command. So it has to give the information about the path information and everything, right? That the main bash shell will provide to the child shell. It is something like, sir, like for example, like even like for example, there are a lot of responsibilities are there in my life, right? I will not be able to do it. What I'll do, I'll delegate my responsibility to my child. I'll say, tell to my son that you do this work, you do that work. Right? I'm delegating the responsibility. So delegating the I'm delegating. So bash shell is delegating the responsibility of execution of this command to the child shell. So once the child shell exits, or when the child shell's complete execution of the ls command, right, the child shell will get killed. And before it get killed, it will give the output to this main bash shell. So it means that once the child completes, it gives output. Then there is one command, there is one function or the system called the exit system call will get called. Can you see, sir? I'm using some system call word. See here, system call I'm using. So what are the system call? I just now I told you fork system call, exit system call, and exit system call. So I just mentioned something on the system call. What is the system call and all? We need not to worry much. You can understand just like a function actually. Oh, it means that internally these functions are executed. Now, if you say, Rajesh, I'm executing the ls command, show me where is fork system call, where is exec system call, how it is getting executed. I cannot show you because it is everything happening in the background. So you should understand that the kernel, it provides all the system call. In Linux, there are more than 350 system calls are there. System calls are there. So all the system calls are about function calls which are embedded within the kernel. So when a user is actually want to do some operation internally, some APIs are getting invoked. You have to understand like this. Some APIs are getting called by your application program. APIs. Those APIs will in turn call the system call which is there in the kernel. That's how you have to understand, sir. So whenever bash is executing any like it is internally it want to do all this operation like creating a child, delegating the responsibility, it is using this exec fork and all, right? Actually this fork and execs are the APIs actually. We can even call the system call also. These are API. This API in turn will call a system call which is in the kernel space. Oh, it means that whenever the bash shell is doing any operation, does it always try to contact to the kernel? Yes, it has to always contact to the kernel. It cannot do itself anything. So shell cannot do anything. Shell will be depending on always kernel only. Clear, guys? So this system calls, we need not to worry as of now. I will tell you after some point after what the system calls are, how to understand this system call. Is it really required for the DevOps engineer to know all the system calls? No, it is not required. Only for the programmers or the developers, right? They will be knowing all the system calls. So similarly, you might have a doubt, Rajesh. This same system call is there in the Linux. Is there is a system calls or APIs even in Windows operating system? Yes, there are there. There are more than 5,000 system calls are there. There are more than 5,000 system calls are there in Windows. Okay. Is the system calls are there even in Mac OS? Yes, sir. Without a system call, you cannot work anything. The operating system will never work actually. So it means that is kernel, Rajesh, kernel is filled up of completely system call? Yes, it is a completely filled up system call. Okay. Now, Rajesh, suppose anyone want to understand how this kernel is working, okay, how this kernel is behaving, how it is working. Will I know about every information about the kernel by going through all these 350 system calls? Yes, you have to go through it. If you go through it, that's what the developer will do. The developer will understand how the system call internally works in the kernel. So when he is trying to understand this system call very clearly, he is internally understanding the kernel subsystem also, or the kernel. You know, like kernel is made up of five subsystem, right? Process management, memory management, file management, network management, device management. We had executed, we had learned in the session 2, right? We had even explained about one line information about each and every subsystem, what it does, right? So that's how. So the kernel is made up of system. It's not only system call, sir. There are many things are there where the kernel is made up of, and kernel will be always be up and running. So whenever user is doing any task in the user space, see, when I go to the Windows, if I'm doing double click on it here like this, I'm opening a browser, fine. But you might ask how this browser is getting opened. Sir, there is some system call internally which is being called in the kernel space, right? Which has been called in the kernel space. So this some system call is getting called in the kernel space. That system call is getting executed by the kernel, then only the browser is getting opened. That's how you have to say. Okay, Rajesh, it means that whatever you do operation by the user space, some kind of a system call will be get called in the kernel space. Correct? Yes, it is. That's how it is. Okay, guys. Any doubts you have? Anything? I know some of you might have heard about this system call or might not have heard, but you don't know how internally it works. So this is how it internally works. It means that for every operation where a user is doing anything, sir, you might say, Rajesh, I'm doing a CD to some path actually. Does any system call is getting called? Yes, sir. There's a system call is getting called. Okay, fine. I'm opening a file, Alice, and I'm typing something. I'm doing some operation, and I'm saying the file. Is there any system call is getting called? Yes, sir. It is getting called. Okay, fine. I'm removing the file, Alice. Is any system call is getting called? Yes, sir. It system call is getting called. Rajesh, I'm doing many operations. Even I have opened the MS Paint also. Here you're doing some operation. Is some system call is getting called in the kernel space? Yes, there's a system call is getting called. Now you understand that without a system call, the kernel never works. That it doesn't work at all. The kernel can understand a language of only system calls. And of course, it understands the IOCTLs, it understands the signals, it understands the file system. Yes, it do understand the different ways, but it do understand with a command also. Now, guys, I need to ask a very, very, very basic question to you, all of you. Okay, what is the basic question is, what is a command? Can anyone tell me? What is a command? Or what is a command? Is command is a shell script? Is it a binary file or it is an executable program? What is the command? Can anyone tell me? Anything which you understand or which you know? Okay. Okay. Now, what is a command? So we execute so many commands. So we execute cd command, ls command, date command, pwd command. You execute a lot of commands in a day-to-day activity, right? But you don't know what exactly command, right? See, command is nothing but it is a executable program. It is an executable program. Now here, if I execute the ls command, so command is being executed. Okay. If I say where is or which ls, you know that the command is in this path actually. Okay, fine. USR bin path. I'll go to this USR bin path. Okay, right, I'll go to this path. I need to open this file, vi, and shall I open this file and check what is VILS? Hey, it is a binary program, man. It is a binary compiled program. Okay, we cannot read it. It is already a compiled program. Okay, fine. Shall I do a file command onto the /usr bin ls? See what it says. Ls command is nothing but it's an ELF 64-bit shared object. It is dynamic length interpreted, not stripped. It means that basically it is an executable program. It is a compiled program. Similarly, if I execute date command also will give current time and date. But if I execute which date, means I want to check the path of the date command. See, /usr bin date. Can I go to open that file, /usr bin date? It is it is an executable program. Same thing. If I want to check the type of file, what type of file it is, I can run a file command. File usr bin date. See, it is also an ELF file. ELF means executable and linking format. We say it is 64-bit LSP executable link file. Oh, it means that it is a compiled program. Some people have a confusion, say that sir, command is nothing but it's a script actually. It is not exactly a script. It could be a script, but it could not. It is not exactly a script. It is a compiled program. Okay. So it means that, sir, what is this compiled program? It means that somebody has written a C program for this ls command. Somebody has written a C program. Okay. Somebody has written a C program. There is a file by name ls.c file. It's a C means, see, whenever you're seeing any file with a .c as an extension, you call it as a C program. Okay, somebody has created a C program of ls command. That ls command has been compiled and they have kept that ls executable under this path. So it means that whether all the commands or whatever you say, usr bin, whether all these commands are executable commands or not, but the compiled program command, yes, sir, all these are compiled programs. You could see that there are a lot of files with a green color. These are all executable commands or nothing but executable compiled program. Okay. What is about this light color, sir? What is this light color? Light blue color. So these are all the soft links actually, or the symbolic links. What is the symbolic links? We will see later. Okay. So right now, what I have to understand that all these programs or all these commands are binary compiled programs. Those are already been compiled. Okay. Now, okay, guys, to show you an example. Okay, to show an example like how this. Can we see an example of, suppose I write one C program and I will show you how to compile a program and how to execute. Can we just check how it works? Okay, guys, we'll check it out to make you understand, to make you a little bit comfortable. Suppose I will write one small C program. I will write what I will do now. I will write a hello.c program. .c program. See what I'm doing. See, in Linux, whenever you want to create a file, we use a VA command and you specify the file name. Many of you already know, but I will get later, after some point of time, we'll get on the VI editors also. I'll be explaining about what is a VI editor in little detail. But right now you understand that whenever I want to create a file, I can use a VI command to create a file, or else I can use a touch command also to create a file. Touch hello.c like this. I can create the file with help of a touch command also. If I do a touch hello.c and say enter, and if I say ls, you could see that there is a hello.c has been created. Now I need to edit this file. I want to add some content inside this file. So I have to use some editor. I'll be using VI editor. You can use any editor. You have a gedit, you have a nano edit, you have a xedit. So VI is a most favorable editor actually, which is used in Linux actually. VI editor we use VI hello.c. So I'll open this file. So I'll go to the insert mode. I'll say hash include stdio.h. So it's a standard header file. You need not to hash include. In your engineering days, you used to include hash include stdio, hash include conio.h, in your turbo C compiler. Whenever you're writing any program, right? Like this hash include stdio.h, you can even use hash include lib.h, something. I mean, some of the header files can include. Int main. So always your program starts with the main. So I'll write a simple program, printf hello world. Hello world. And 0. And this is a very simple program, C program, which we are just trying to print this hello world. Printf is a API or it's a function which prints this string actually. So if I save this file, shift colon WQ explanatory and say enter, I'm saving this file. Now I want to compile this program and I want to execute it. How to compile? Already there is a GCC compiler which is installed in your machine. So I say GCC. GCC means GNU-C compiler. So this is the same compiler which Richard Stallman has written, right? Which I explained about in the second session. GCC compiler, GCC hello.c. Say enter. So GCC compiler is not there, guys. So we'll install the package yum install GCC compiler. Very strange. Why it is not there? Okay. This is a tool set. This is a compiler is getting installed, right? See. See, 305 package is getting installed, sir. Oh my God. We don't have that much disk space also. Let's see. So the installation is going on. So what I was trying to say here that, okay, let it go. So I'll duplicate this session. So here I have created a file by name hello.c actually, right? So if you see the hello.c, this is a C program, sir, actually. So these are the header files actually. Okay. I mean, we need not to know all the in detail about all these things. Header file basically it includes the function declaration and the macro definition. Suppose you are declaring a macros. I think hope you have studied the C language and all in your engineering days, right? But this header file basically it has all those function declarations, okay, and macro definitions will be declared here under this std.h. That's what we included. Like for example, we have printf. If you say Rajesh, where is the printf function declaration? You will find in std.h. That's what I include this file. Okay, always the C program, whenever you execute it, it always starts with the main. So this is the point where the program will start executing. So within the main, actually, you have open bracket, and here you have one small API which you use, the printf. So what the printf will do? Printf is basically it is trying to print the string to the standard output or to the screen or the monitor, we say. So when I execute the command, where this output should come, this output should come to the screen or the monitor, right? And here always main always it expects the return value 0. That's what I'm using. Explicitly I'm mentioning the return value 0 itself. And this, and it has to get close from this, because from here the execution of the function will stop, because main as soon as it enters side, it executes all the instructions, and here it has to even know where I should get exit, right? When it sees this flower bracket, close the flower bracket, the main function understand, oh, I need to exit out from here. So the function execution stops after this flower bracket. That's how this program will always get executed. The same thing is in Java, same thing is in .NET. If you take any language, there you have to mention that to the function that where is the entry point of the function. For the main, the entry point is this curly bracket, the curly open the flower bracket. Oh, the main understand, oh, from here I should start, man, the function execution. Okay, it'll try to execute this statement, it'll try to execute this statement. And now there has to be an end, right? It has to understand. So here it gets, okay, guys. So it means that now we have installed all the packets. So this is the command yum install gcc. I don't know what is the letter. I just put star and I every package is getting installed here. So what I will do, guys, I will say gcc. Let me clear the screen. So I use a clear command to clear the screen. So I'll say gcc hello.c. Watch carefully, guys. Now you could see that it has compiled a program. The output you have got is a.out. You call it the assembler output a.out. Now if you execute a file command on the a.out, can you see it is an ELF LSB 64-bit executable program, and it is a non-stripped, actually, not stripped, and it is a dynamically linked, interpreted this one. So this has become an executable program. If I open the VI a.out, see, can you check? Oh no, man, this is an executable program. I cannot read it like this, right? Some people are very clever. What happened? No, Rajesh, there is an a.out. Something I want to see, man. What is this executable has? I cannot just do a VI a.out. and see the content, right? It is in a compiled program actually. It's in a compiled format. Some people are very smart. They'll say strings command, strings a dot out. See, oh, something is there. No, this program is doing something. See, okay, fine. Okay, they'll understand something to strings actually. Now, how to execute this a dot out program? I'll say dot slash a dot out. See, now the program has been executed. Now, what I was trying to tell you all this time that if you go to the slash user bin directory and say ls, do you see all these commands? These commands all the C files or C programs? Yes, it is all C programs. Those are compiled programs and they've kept it here. Okay, fine, Rajesh, no problem. I got your point, what you're saying. But here, when you compile the hello.c program, you got a dot out, right? So a dot out, is it a default output file you'll get when you compile the program? Yes, sir. So let me remove this file again. Let me remove this rm command space hyphen f a dot out. This is a command to remove a file. Rm space hyphen f, remove a file forcibly and a dot out and the file name and say enter and say less. So the file is removed now. Now if I do again gcc hello.c, it will compile the program, but the default output of the file will always be a dot out. Okay, fine. But I don't want to have a dot out, Rajesh. I want to have something like a output as a Raj as a file or Raj or Rajesh, anything. So I'll say gcc hyphen o Raj and specify hello.c. Enter. See, you got an executor by name Raj. See, I can execute a program dot slash Raj. See, the program will get executed. Even you can execute a dot out also like this. It will get executed. But you don't want to get the output of this name. You want to get with your own name. Then you have to use a hyphen o flag. Hyphen o means output. Similarly, guys, all these commands usr bin under usr bin, all these commands, whatever are, they are all C files, .c files. Like for example, there is some file might be there like ls.c. Somebody has written a program of ls.c. Then what happened? Somebody has compiled like this gcc hyphen o ls.c. Now don't you see that it will create an ls as an out executable? So it will create a ls command. So what they'll do, they'll move this ls command like this ls command to the slash user bin directory. I move this Raj into slash bin directory. Now you could see that I need not to execute like this dot slash Raj. I can just execute like this. See? Can you see here? Guys, see here? Suppose same program, right? Hello.c. Sorry. I'll move this hello dot not sorry. Hello.c. I can add some more one more string I can add actually. Something hello team. I'll compile the program again. gcc hyphen o something Mahesh hello.c. I got a Mahesh as an executable. Can I move this Mahesh? The slashes are bin. Yes, you can move it. See? Now I'll just say Mahesh and enter. See? It's getting executed. So now you understand that all these commands are executable commands, right? And those commands are but it's a .c program. They have been compiled and the output or the output of that file has been moved to the slashes of bin directory. That's how when you're executing any command ls or date command, those are being executed. Is it clear, sir? Are you okay till here? Have you understood? Any doubts you have, please let me know. No? Okay. Somebody is very clever. He'll say, Rajesh, I want to see the source code of ls.c, man. Okay, you are saying something. Source code of ls.c. So he will get the link. Oh, core utils ls.c at master git. Okay, somebody let us see what is it. So see. Oh man, this is a program of ls.c. Yes, sir. See hash include. See. Oh. So Rajesh, shall I take this whole program and I will compile and I will execute it? Oh, I don't know. It will work. It might not work. I don't know. Let's see if it really works. See, there are 4,726 lines are there, sir. That much big program, sir. It will take a lot of time, sir. See, this is a source code of LS Raji. It's all it. This is what it does. Yes, sir. This is all it does, sir. See, I cannot copy, sir. It will take time, but we can copy later. So is this whole program will be copying into a file, and I will. Yes, sir. Okay, that's how it works, sir. See, size of function. See, MB align. I know all these functions. Okay, I can make out, but you guys will not be able to understand. So that's all. Xlog die. I know all these functions. These are all APIs. Xmalloc. I know all these functions. So stuck Dave. See, he's using these are very big problems. See, 4,000 code of is there. So similarly, Rajesh, can I see the date output date.c commands date.c file? Yes, sir. You'll get date.c. See, under the same core utils only you're getting. Okay, fine. It means that ls.c it is coming from the core utils package. Correct. Rajesh, is there any way to check it? Suppose date command is there, fine. Date, ls command, all these commands are from which package these commands are coming from while installing Linux? Yes, sir, we can check it. See, we know which, if you say ls, it is showing me the path actually. If I execute RPM, I'm just telling you, don't worry about now what I'm doing now. /sr bin ls. See, it is coming from the core utils package. Don't worry now, as of now, you'll get to know about this commands and all later. I'll be taking a separate topic of RPM, M, and DNF. At that time, I'll be showcasing you everything, all these things. But right now, what I'm trying to do it here, that I'm trying to explain you or tell you that this command is coming from which package. Oh, it is coming from the core utils package. The same core utils also you're seeing here only. See, core utils src date.c like this. Okay, somebody has written a core utils as a directory. Under that, he has placed all those commands. If I do a srcc cat.c, chrp.c, chmod.c, see, you are executing the command, but these are all source files actually. These are all .c files. See, so many commands are there like this. Correct, guys? I execute PWD, current directory, but how it is PWD? PWD.c is there. This has been compiled and has been kept, sir. See, this is a C program like that. These are the source codes, sir. It means that if anyone want to really understand how exactly ls is working, can you tell me the code of the program is? You can go through ls. Similarly, PWDC, cat.c, any file you can go through. This is what the developer does in the industry. He will go through the source code and try to understand everything. And whatever the changes required for him now, he will do changes into this file only. And all these things are in the Git actually, GitHub. So he'll be doing changes, everything, and he'll be pushing to the GitHub actually, like that. Clear, guys? Okay. Now coming back here. So what I said here, like whenever any shell is executing any command, it will always execute the command with the help of a path unknown variable. So whenever I'm executing any command, like when I say ls command, so what the shell will do, shell will try to search for that command, where that command is there. So with the help of a path environment variable, it will try to check where the command is coming from. Once it understands that, oh, ls command is in the slash or bin directory, so what the shell will do, shell will try to create one subshell. How it will create a subshell? With the help of a fork system call. Okay. After creating the subshell, the main bash shell or the father, he has to tell to the child shell, no, hey, you execute the ls command. So it has to call an exec system call. So exec system call, when it calls, it will try to say the information that, hey, there is a ls command under slashes or bin, user bin, go to that path and load that program and execute it. Okay, the child shell, what it will do now, it will go to this path slashes or bin and it will load this path and it will execute it. Once it completes execution completes, now the shell will return to the main bash shell with the help of an exec system call. As soon as the shell gives the output of the ls command to the main bash shell, it get exited out with the help of exec system call, and this child shell will get killed. That's all. Similarly, what is happening there? Now here what happened? The main bash shell. See, the main bash shell, he might be doing multiple operations. He might be executing the ls command. He might be running some MS Painter. He might be running some game. He might be executing a very big program like that. So many operations the shell is doing. There are multiple different applications are running all together because it's a multitasking operating system. A single shell can run multiple programs, right? Multiple things. So do you think that for all these operations, different operations, do you think the bash shell will create a subshell? Yes, it will create a subshell. For this operation, a subshell will get created. Okay. Cool, create the main bash shell with the help of a fork and exec system call. Again, one more operation you are doing, or one more application you are running, one more subshell will get created. Or one more operation you're doing, one more work you're doing, or one more subshell will get created. Like this, for every work, for every execution of any application program, the main bash shell has to create so many subshells. And that subshells will be running on behalf of a bash shell. Now you'll ask the question, rather does the bash shell itself will do something, or it'll always delegate the responsibility to time shell? So 95% of the time, always it'll try to delegate the responsibility to other subshell only. It doesn't do, because he's the main godfather, man. He's a father. He's a father. Why he will do the work himself? He will create a lot of childs and he will tell that, hey, you execute this command, you execute this command, you run this application, you run this application. It always delegates the responsibility to the child shell. And the child shell will happily do the work whatever the father has the main shell has delegated. It does it. Once it does it, it gives back the output to the main bash shell and it will get exited out or it get killed. Clear, sir? Sir, now are you able to tell if anyone asks you how exactly internally the shell works? Whenever any command you're executing or whenever any operation you're doing, shell always has to create a subshell. Clear, guys? Okay. Now, coming back to the bash shell, this bash shell has lot of features, sir. It has lot of features. We need to understand. See, there are two things, sir, where you need to learn actually. Whenever you want to become a very good script writer, shell script writer, you say that, Rajesh, I want to become a very good script writer, man. How I can learn writing a very good scripts? There are two things, sir. One, you need to know all the commands in your system, or maximum commands which you know. You should understand. You should know about the commands or what are the options you use along with that command and all that and all. You should know. And the second point is that actually you need to even know about the shell features, how the particular shell behaves, right? So you should know all these things. Then only what happened, right? You will be able to write the shell script very comfortably. It means that you will get a knack or you'll get an idea of writing a very good scripts actually. And obviously, and of course, right, you need to even watch a lot of scripts which are already been written. Many people have written the shell script. What you have to do now, daily go and watch that scripts. You are not understanding. Sometimes you might not understand what is each and every line does. No problem. You keep watching. Once you keep watching, a lot of trigger will come to your mind. Then you start dwelling it. What this line does. What this line does. When you start dwelling yourself more and more by understanding or going through this each line of a script, right? Then you will get to know the. Then you will start learning yourself. That is the point where you will start learning a lot and you will become a good in mastering of shell scripting someday. That's how. You cannot become a very good script writer in 1 or 2 days. No, it's not possible. It needs some time, over a period of time, 4 5 months, 5 6 months. Continuously, you are working. You will get become a mastery after some point of time, like that, right? So it will take a time, sir. So that's how you need to. If you are practicing every day, you will get it. Similarly, with any programming language. Let it be Python, let it be Java programming, or let it be .NET, let it be Node.js, any programming you are learning, right? You have to put some effort on a day-to-day activity to understand a new concept every day. If you are learning every new day, right, one day it will come that where you have become a mastery in that particular programming language. Or else it is very difficult, sir. You cannot become in 1 or 2 days, 1 week. No, you will not become like that. It's not possible. You have to work every day, then only you'll get to know. So similarly, shell script also we need to get to know every day. That is our stuff. So okay, now what are these bash features? So bash features. What are the bash features? Okay, there are a lot of bash features are there. Sorry guys, I have not even come to what are the different types of shells are there. Or else first let me cover the different types of shells actually. It is good that we should know what are the different shells which came into the picture. See, in 1970s, during 1970s, when Unix operating system came, right? At the same time, there is a shell which came known as a bound shell. This shell was developed by the person by name Steve Bond. Okay. The bound shell, in short, we call it as a SH shell, sir. Call it as SH shell. So this was a very famous shell, and lot of it carried on a lot of new features or a lot of features it had carried on. So that's what this shell existed for a very long time. After some point of time, sir, there's one shell came. The second shell came, which was a corn shell. It was developed by the person by name David Korn. So in short, we call the case corn shell as a case shell actually. Case shell also has a lot of features, but it had many other features which were missing in the bound shell. Bound shell that was no that was implemented in the corn shell, and corn shell was also heavily used in many places. You know, like in Solaris, they use this corn shell. Default corn shell was the shell in Solaris. Similarly, our IBM AX also used the corn shell heavily. So a lot of people who have written, lot of people are during 90s, right? They used to write a lot of Corn shell scripting. Even today, in some of your machine, if you see in some of your Linux machine, you could see that there are a lot of Corn shells are there. Even in our company also, there are a lot of scripts are there which are written in a Corn shell. So you can execute always those scripts under the Corn shell. Okay. So most of the features, whatever you will find under the bone shell, you will find almost all the features plus some more extra features in the corn shell. After the corn shell, what happened? There was one more shell which came known as the C shell actually. This was developed by a person by name Bill Joy. And what happened, right? This C shell, it also has all the features which is having the bone shell as a corn shell. It has some more extra features which I will discuss after some point of time. Okay. What are those features? I will discuss some point of time. Yeah. This what see what the seashell was, right? Suppose tomorrow you have to write any seashell script actually. See, to be very frank with you all guys, right? Today in this today's generation now, right? Nobody will ask you to please write a script under the seashell, please write a script under the conch shell, or please write a script under the bound shell. Nobody will ask you these days because these shells almost they have been obsolete actually. It means that they are no more using. Nobody is using conch shell or the seashell in industry now actually, because like this bash shell has replaced all these shells actually today. That's the reason people are not using bone shell. In you need not to separately learn these shells and all. No, not required. Only you need to learn only bash shell. That's all, sir. You don't have to learn any other shell. So what is the syntax? So for the C script writing, the C shell scripts, right? You need to follow the same syntax as you used in your C shell C program. The syntax are same as in the C program, because the Bill Joy he used the C programming, and he has written a shell script actually, a shell actually, which follows the same trend as what is in the C program. What are the syntax which are there in C program? The same syntax he has used to write the C shell. Obviously, you have to use the same syntax while writing the C shell script also. Okay, so this also has many features. It has many features like command line editing, command completion, history command, date command, aliases, PWD, like arithmetic solution, variable substitution, like that. Many features were there, right? Now what happened after this? What happened, right, guys? In 1994, actually, 1994, under the Free Software Foundation, which I discussed earlier, right? Under the Free Software Foundation, some people together they joined and they developed a shell which they call the Bash shell, actually. So Bash shell is a superset of all these shells. Bash can even support, it can even execute the script which are written in the C shell. It can even execute the script which are written in the C shell, K shell. It can even execute the script which are written in the bound shell. So that's the reason Bash is a superset of all these shells. So what are all the features or what are the syntaxes are there in the shell? No, all the syntaxes are supported by the Bash shell also. So Bash is a main shell. So nowadays we are using only Bash shell. Bash shell is been used from last almost like from last 20 to 25 years. So till now Bash has not been replaced by any other shell. Bash is a super shell. So even today also we are writing all the Bash shell scripting itself, right? So Bash shell was was developed, and this Bash shell was the shell which was integrated into the Linux operating system. When Linux software developed the Linux operating system, right? During that time, along with the Linux, now Bash shell was also included along with that Linux operating system. So Bash is a very favorable shell. Everyone uses the Bash itself. Nobody uses the Corn shell or the C shell, right? C shell again, yeah, it was used again by Solaris also, and sometimes Solaris was used even in sometimes the HPX operating system, right? They also use the C shell as well as the corn shell. They were using both the shells, right? Like this. Okay. There are many big history there. I'm not discussing all these things right now. Okay. So this is a very, very small basic history of how this shell came into the picture. Okay. So we have to only learn the bash shell. Okay. Now, what are the features of the bash shell? Why bash is so favorable? What it makes so unique compared to other shells? Because bash has lot of features, sir, actually. What are those features actually? To name a few, something like command line editing and command completion. Variable substitution. arithmetic substitution, and command separators. Like that, there are many features are there, sir. These are some of the features of the bash shell. A lot of features are there, but I'm just naming a few features for you guys. Okay, these are all the features of the shell. It means that Rajesh, do I have to learn all these features? Yeah, to some extent, yes. Please learn actually. That's a humble request from my end. Okay, you should know some of the things actually. Okay, without these features, can't I learn the bash shell? Guys, can you see this one? All these 10 lines.
Yeah.
It is slowly loading, right? Because
No,
I'm
Rajesh,
very
from my
because
side, you're fine.
no.
It's fine.
So okay, we have to learn all these features, sir. It is good to have some knowledge on these features. Okay, it's no, it's not like that because you have to know certain things actually. Because all these features we'll be using in our scripts actually. We are using in the scripts actually. Now, okay. So shall we see this one by one? What these features are? Sir, we have not started anything on commands, sir. Commands is a beautiful topic. Maybe tonight at 10 o'clock we will start that. Lots of commands are there. Very beautiful commands. Lot of you need to know in detail about many of the commands. Very important, one of the few of the commands is set and awk. Some of you might have known all this thing. Some of you already know the set and awk. So you need to set and awk, as well as in the upcoming classes where I'll be writing a script. So I'll be using the set and awk heavily. So you have awk programming itself a separate topic in our class session. So and also this set. So this when I start working on the scripting, right, I'll be using all the set and awk command. Many more commands I'll be using. So it will be a very good session for you guys to learn many more advanced things which I'll be showcasing in the class actually. So these are the heart. Tomorrow, if you go for an interview, if they ask you to write a script, no, if you are using the set and awk heavily, you showcase to them saying that they will get impressed with your answers because they'll know that, oh, this guy knows something better than others. That's how it is, sir. So you should know, you should have all this information. So set and awk, there are many commands are there. Tonight I will be explaining all those commands, as well as the user management and Linux, permission management and everything. Those are the separate topics. Again, we would be taking it tomorrow actually. Okay, so that's how it is. So now, so what are these features? So okay, coming back here, what are the features actually? Okay, guys, I think I missed the session. Okay, I think permission is lost. Right. The first is nothing but it is a command line editing and command completion. What is command line editing and command completion? See, command line editing is something like suppose I am having two commands. Okay, what are those commands? I'll say ls command. Ls will list out all the files and directories in the present working directory. That's a command. I have a date command. Okay, and there's one more command, the who command. Command. Who command will show you who are all the users who are logged into a system. See, root user has logged into system, root has logged into system. So this it is using these three terminals actually. Okay. So there are three users who has logged into the system. Okay, fine. So these are some three commands are there. Now if you say Rajesh, I want to execute all these three commands at a time, man. So I can use a ls command, semicolon date command, semicolon who command. See, I am executing all these three commands at a time. Now, if I want to execute the re-execute the same command, what I will do, I'll say ls date who command. Now, when I typed it, you saw that actually that I have wrongly typed. Instead of date command, I have put data. Okay, fine. So what to do? We'll say that, hey, no problem, man. Navigate to that path, edit that string, remove that string. So here, edit that string and replace with the proper string. Right? That's how you say. Now, how you are able to navigate to this path? You are able to move your cursor anywhere within a command line, right? In the command line, you are able to move anywhere, right? This you call the command line editing. Now you say, what is the big deal, man? We were doing all these days, and what is it? I can navigate anywhere in the command line. What is the big deal? What you're saying, command line editing? It means that this bash has a feature that you can move your cursor anywhere within a command line. So what is the big deal in that? So the big deal is that actually this corn shell or the C shell earlier they didn't have this feature. It means assume that you have mistakenly typed wrongly something like this. You cannot take your cursor back to here and rectify. It is not possible. So during that time, what happened? You have to do Control C again. You have to retype it again one more time correctly. It means that there is no option to move your cursor backwards or anywhere to edit it. You cannot edit it. That's what. Whereas in a bash shell, it has a command line editing. You can move your cursor. Can you see, sir? So my cursor is here, sir. Right? Suppose I want to move to the front. So I'll say Control A. See, Control E. See, I'm using a shortcut in my with my keyboard. See, Control A, Control E. Okay, Control A. See, Escape F, Escape F, Escape F, Escape B, Escape B, Escape B. See, you are able to do any kind of a thing with the help of a keyboard shortcut because that your bash shell supports the command line editing. Clear, sir? Command line editing. Right? Now, what is a command completion? Command completion is something like you say, Rajesh, I want to execute one command. There's a command known as a lsattr command. Lsattr command. There's a command. Execute command, I will get some output. I need not to worry. What is this output? Lsattr will list the attributes of a file. Will list the attribute of a file. You need not to worry. What is this? We will see later. If it requires, I will explain what is lsattr, what is setattr, what is getattr, and all. I will explain you. This will show the attributes of the file, some special attributes for the files. Okay. Now, if you say that, Rajesh, I want to execute this command lsattr, do you have to type it completely? Okay, let's see how to do it. When you do a ls, and if I press the button, tab button twice, see, it will show me all the commands which starts with the ls blk, ls gpio, ls issue, ls ipc. See, can you say there is one more command, ls attr? Okay, fine. I will type one more. I'll press one more a key, and I'll say tab. See, it will do a auto completion, right? So it means that always when you're using any tabs, right? Tabs will always do a command completion or the file completion. See here, I want to open etc password file. See, I'll say vi slash et e and I'll say tab. See, it has completed. Pa tab tab. See, it will show me all the files which is having a pa. Okay, I'll say press s and I'll say tab. See, so like that you can do a command completion or the file completion with the help of a tab. This is the tab. If you press tab, right, this is a feature which is in the bash shell. Suppose you're working a conn shell doesn't have it. Whenever you want to open the file, you have to type it completely like this, sir. Like this, you have to type it completely. In the bash shell, we have a completion where if you are pressing tab more times, you will get an idea how exactly the auto completion will happen or the file completion will happen. So that is what this is one of the feature. Though it's looking very small, but these are the features which is provided by a bash shell. Okay, fine. Now, so what is the history command? You know, right? Always we execute lot of command. I execute ls command, I execute date command, I execute pwd command, I execute who command, I execute who am I command, right? So many commands I executed. What the shell will do, right? Shell, what it does, the main shell, it has its own buffer, sir, or it has its own memory internally within a shell. It has its own memory, sir, or the buffer actually. This buffer size of the shell, uh, wait, I will see if in case if it is there in some other place. Okay, I'll write it down here itself. So the bash shell intern had its own buffer, sir, memory we call. Buffer is nothing but it's a memory. Okay, internally it has. So the bash maintains its own buffer, Mujhe. It is a like a circular buffer memory. You can even Google, sir, what is circular buffer memory? Circular buffer memory. You'll get articles. We can go through all this circle buffer memory. So what happened, right? This circular buffer memory, the shell intern maintains actually. Okay. Now, whatever shell is executing any command, whatever the shell is executing any command, all those commands entry will be placed in this buffer shell, sir. Like this. Like this it maintains actually. Like this it maintains. Now, if you ask me the size of this buffer memory, it is 8192 bytes. So 8192 bytes is the size of the buffer memory. Okay, it can hold this number of bytes. Now, when shell is executing all the commands, whatever in the command is getting executed, all the entries will be made in this shell in this circular buffer memory. Okay, if a user want to see what are all the commands which he has executed, right, he can execute a history command. See, it will show me the okay. Earlier I had opened this file. Oh, I had executed this commands and all. Fine. I had opened this file. See, I have executed till now. I have executed. See, and it is showing you the line number also, sir. Sorry, it's showing you the number also 1, 2, 3, 4 like that. Now the question comes. One of the very important intro question they'll ask you, sir. The history. How many commands the shell will maintain, sir? It will maintain thousand. Sorry, 1,000 entries it can make. 1,000 entries it can make. Of course, it is configurable also. You can increase to more than 1,000 also. But by default, most of the shell it will make always 1,000. It means that there will be like a 1,000 entries will be there like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So it means that this shell buffer memory will be there till your shell exists. Means your till your shell is up and running. As soon as the shell will it will get exited out. If it get killed, all this shell, all this buffer content, what will happen, right? There is one file known as a bash underscore history. See here, if I do lsfna, there's a bash underscore history. So as soon as the shell will get exited out, I'm sorry guys, as soon as the the shell will get exited out, whatever the content which is the history, that will be copied to a file known as a bash underscore history. See here, if I open the bash underscore history, whenever any file starts the dot, it's a hidden file, right? I told you, right? So bash and see, it will maintain all the information about all the commands what you executed. So it means that, so whenever they ask you, okay, sir, okay, so they'll say that, okay, what is this history command, sir? Sir, history command is nothing but it will show me what are all the previous command which I executed. Okay, if I execute a history command, what will happen? You say that, sir, whatever command which I'm executing, right, the shell will maintain, internet maintains one buffer. In that buffer, it maintains, in that memory, it maintains all the commands which I'm executing. Okay, fine. Sir, as soon as I exit from the shell or I'm out of the shell, the content which is in the shell buffer, that would be copied to one file known as a bash underscore history. Okay, is this is a permanent file? Always will be there. Yes, sir, it will be a permanent file. So all these entries of your buffer content will be maintained or will be written into this file. Okay, fine. How many entries are there? Sir, 1,000 entries are there. It will maintain 1,000 entries, sir, not more than 1,000 entry. Okay, fine. Sir, how to check which is your history file or history file size? Can you just display it? Yes, sir. There is one variables. Shell variables are there. What is that? Echo dollar hist file underroot slash bash underscore history. Oh, it is a history file. Oh, there's one variable. Like how I did earlier, echo dollar shell shell, right? It will show me the shell. Echo dollar path. Okay. Oh, it will show me the path and well. Fine. Now I'm just saying echo dollar hist file. Oh, this is a history file. Oh, it means that whatever the history, whatever the buffer content is there, that would be written to this bash underscore history file. Okay. When as soon as you exit out from the shell, all the content of the shell buffer will be written into the bash underscore history file. Okay, fine, sir. I got it. What is the size, sir? Is there any way to check the size of the bash history file? Yes, sir. Echo dollar hist file size. 1,000. Super, sir. It means that this can maintain 1,000 entries. Beautiful, sir. Now the question comes. Some of our very intelligent guys in the industry, they'll ask you, Rajesh, why we need all these things? Okay, you are saying so many things. I understood. I got it. Okay, why you need it? Okay, sir. See, for example, Okay, guys, did you understood the problem statement? Did you understood till here?
Yes, Rajesh.
Okay, now the question comes actually why we need this history, why the shell has to maintain this history, and why it has to maintain a dot bash history file. What is why it is required, sir? You tell me first. They'll ask you. Okay. Let me tell you one thing. It's a very beautiful concept. Why it shell maintains all these things very nicely. Why it has all this concept? I will tell you now. Now, see, sir. Whenever you are executing any command, I'll connect all these dots later. Just try to listen what I'm trying to tell. Now, whenever I'm executing any command, when I do an ls and enter, ls command is getting executed, but how it is getting executed? Now you know that shell will always search for any command execution from the path environment variable. So with the help of a echo dollar path, right? So it understand whether the ls command is in the slash user share model bin, no. Slash user local has been no. Slash user local bin, no. Slash user bin has been no. Slash user bin, yes. Oh, this is the path, sir, where the command is ls is there. So you know that shell will go and the shell will try to execute that command. Now here in this case, shell will not do it. The subshell will do it, right? Because the shell will create a subshell with the help of a fork system call, and with the help of an exec system call, the main shell will try to delegate the responsibility to the child shell that you please execute the ls command, right? So what is happening that it always has to search for the path. Whenever any command is getting executed, always shell has to search for the path, right? Now the thing is that actually when you are executing any command for the first time, shell will always search in this path, sir. Suppose assume that I'm executing some wrong commands like this. There is no command with this name. So when I enter, what the shell will give the error? Shell will give the error, command not found. Even you have seen many times, bash, command not found. Now what shell is doing here? It is how it is actually saying that this is a command not found, because shell is treating this as a complete command. It is searching whether this command is in the slash user share model bin, no. Slash user local has been, no. Slash user local bin, no. Slash user has been, no. Slash user bin, no. Slash root bin, no. Nowhere it found this command, sir. This command is not there in this path environment variable at all. So when it doesn't found in this path variable, shell will throw an error saying that command not found. That's all, sir. Whenever you are executing any command, which is a proper command, no, shell will always search for this path and will execute it. If that command is not there in the path variable, shell will always throw that command as a not found. Okay, fine. Now, sir, suppose assume that I'm executing a proper command, ls command. Does this ls command is being searched in this path always? Yes, sir. For the first time, whenever shell, what the shell will do, no, sir? Shell will always check the information about that command. Okay, what shell will do first? Shell will always search in its shell buffer whether that command entry is there or not. Like here, if I execute the history command, here the ls command is there, here the ls command is there. Okay, this ls command is there, here the ls command is there, here also ls command is there. That you have executed many times. Now what the shell will do, whenever you are executing the command for the first time, shell will always check in its shell buffer or it's in a circular buffer whether that command is already been executed or not. Oh, it is not executed. Okay, fine. Then let me go to the path environment variable to search for the command. Go to this path environment variable and search the command. Okay, under this path, it got to know that oh, ls command is there under this slash bin. It will try to go and load that command and execute it. Again, what happened? One more thing is there known as a hash tables. Very important, sir. Most of you doesn't know what is hash table. The shell internally maintains a hash table like this. Hash table. Some of you might have heard about somewhere hash tables and all, right? What is hash table? Somewhere you might have heard, right? Rajesh, hash table I've read in data structures, man. See data structure. Okay. What is it? Something like key and value pair, man. Hash tables. Yeah, that is a key and value pair. So your shell maintain internally hash tables, sir. Now, I'll change the definition now. Whenever shell will try to search for any command, whenever it try to load and execute the command, before it get into the path environment variable, shell will always search for that command in the hash table first, whether the command is entry is there or not. Oh, the command entry is not there in the hash table, man. Leave it. Then the command will search in the shell buffer, whether that ls command has already been executed. No, it is not that. Then note it will go to the path environment variable. The third step is the path environment variable. Now what happened? We say hash. See, shell maintains the hash table, sir. You could see that. See, ls command has been executed. See, 7 times ls command hits 7 times. See, when I execute ls command, oh, this is the 8th time. Oh, 9th time. Oh, 10th time. So when I execute hash, see, it maintains the count. Beautiful, right? All the commands, whatever you're executing, shell maintains a hash table. It maintains the command path as well as it maintains the hits, how many more times the command has been executed. Now, shell will always search in this hash table first whenever you're executing any command. If that command it founds in this hash table itself, shell will try to go and load this command and execute it from the hash table itself. Okay. Now, when it doesn't found it, then shell will try to go into the shell buffer or the circular buffer if there is any command with the name ls. Oh, there is no command with ls. Now what happens? Shell will go to its path and variable. Oh, finally it has to get from here at least. If here also it is not getting, now shell will throw an error, command not found, like this. Clear, sir? Is it clear? Did you understand the flow of the command? How the command is executing by the shell? So there is a concept, something you newly learn. One is a hash table. Oh, shell maintains some kind of hash tables. Okay, fine. And shell maintains own buffer memory, which calls a circular buffer or shell buffer memory, right? And the third is that path environment variable. So with the help of all these three things, shell will always search. First, shell will search in a hash table, and then if it doesn't found an entry in the hash table, shell will try to search the command in the shell buffer. If the shell buffer is also not there, then shell will try to search in the path environment variable. Then only the command will get executed. Okay. So now coming back to here. Okay, fine. Rajesh, I got to know what you're trying to tell you. What you're trying to tell. Okay, here always shell maintain the hash table. Okay, so let me execute the hash. Okay, okay, these are the commands. There are so many commands are there, Rajesh. Is there any other commands if you execute the entry will come over? Let us see, sir. If I execute chattr or else if I execute the if config command. If config command is not there, I have to install the package. Okay, fine. If I execute the free-m command, or it will show me the buffer and all. If I execute a diff-h command, okay, it will show me a disk. It is showing you the disk free size. Okay, what are the disk? What are the different file system mounted, and what is the size of the disk file system? Everything df-h is showing. Now, if I execute a hash table, see, sir, free command entry it has been made here. Df command the entry has been made here. See, it has executed only one time. Okay, Rajesh, it means that for the faster execution of any command, the shell will maintain a hash table. For the fast execution, you see that how fast the shell is executing this command. Do you think that every time it will go into the path and always it will search for the command, whether the command is there in this path, whether the command is there in this path? Not required, right? For the first time, yeah, shell will always search for this command in the particular path. Yeah, for the first time, yes, of course, it will go to the path variable. It has to search, it has to load and execute. From the second time onwards, shell will never search for that in the path and variable. Shell will always search whether the command is there in the hash table. That's how it will try to load that command from that hash table and it will try to execute it. Clear, sir? Any doubts you have till here?
No, Rajesh, it's good.
So how do you understand? Now many things are clear, right? Many things you got to know that okay, many things I didn't know today I got to know, right?
Yeah.
Some of you say that, sir, I got to know today only. I didn't know all these days, right? This is
Yes,
nothing
Rajesh.
but is a bash programming. We say means you when you say that's sir. That is what the difference between the DevOps and developers are. Developers will know everything, sir, end to end. That's why people want to get into development. Means because they will learn many things, sir. DevOps are something like they are support engineers, sir. We will not be knowing that much. But if you have an or if you have an enthusiasm to learn or to do it, you can learn many. But it depends upon your no, it depends whether you want to learn or not. Like if you want to learn, you can dwell all these things you can learn. Every information is available in the Google, in the books, and everywhere you can learn. So that's the reason developers, you could see that they are learning fastly because they are into development mode. They want to learn many of the new things and all. They will be in a development mode. In that way, they will learn many things. So that's the reason many people, after they complete out their computer science, they want to get into development. They don't want to get into support or something, right? Like us, how we get into DevOps or support. They don't want to get into that. They know that there is not much learning curve in that area. The learning curve is more in development activity. Okay. In that way, I'm not degrading that DevOps is not good, but you can make out that the DevOps engineers, right? You ask, right? Maximum he will be knowing very few things only. He might not know internally. He'll say that why I have to learn all those things. It is not required for me. So that's what each and every DevOps engineer will say, like that. Okay. So now, the question comes now. So this one of the guy had asked me a very long back actually, Rajesh, you were said fine. I understood whatever you're saying. It maintains an history, it maintains a hash table. Hash table I understand fine, it needs it. But what about the history command? And why you are maintaining the content of this history, everything in your dot bash underscore history? And the dot bash underscore history, the content is 1000, means 1000. This is one of the entry questions. They ask how many commands or how many entries can be made, can be saved in the dot bash underscore history. It's a 1000 entry. How to check it? Sir, there is one shell variable is there. Echo $hist file size. This is the shell variable. With the help of the shell variable, you are able to display the hist file size. Okay, okay, fine, sir. Now, what is the use, sir? What is the use of this actually? Very interesting, sir. I read one of the article. One of the guy has explained it very clearly why this is all required actually. So through that, I got to know some information on this. What? Why? Because see, whenever you are executing any command, whenever you're executing any command, all those commands are placed in a buffer, right? If I execute a history command, I will get to know that, oh, these are the commands I executed. Oh, hash command also executed, ls command, fit. See, now I execute so many commands. All these commands are there. Whatever each and every line I'm executing, sir. Even I'm executing this, some nonsense I'm executing. See, even this entry will also be made under the history. Will also, whatever you do, sir, it maintains everything, sir. So whatever a user is executing in anything in a command line, it maintains, as well as it gives you some numbering also. See, it starts with a 1, 2, 3, 4, up to 1000 it will go, like that. So beyond that, Rajesh, beyond 1000, what happened? Whatever these upper commands are, that will get flushed off, sir, because it's a linked list, right? So it will be clearing of all these things actually, and only from the bottom only the append will be added up actually, like this. Okay, Rajesh, if I want to execute the free command again, man, okay, it is having some number. Can I execute this with this number? Yes, sir. Exclamatory. See here, this is 39. See 39. See, can you see it is executing this command? Oh, super, man. Oh, it means that I can execute any command with the number. Oh, yes, sir. You can. ls command 27 is there. Can I execute? Oh, exclamatory 27. Ls command is getting executed. Okay, beautiful. So it means that actually all these commands are executed with the help of this number also. Okay. So this is the entry which has been made by the shell. The shell. Shell is maintaining all this entry. Shell will use this actually for the faster execution in the near future. Okay. So now what happens that actually when the shell will get exited or when the shell will get killed, the output or the whatever the data which is there. See, sir, now this is the history which is maintaining, correct, right? Now somebody will say you, hey, Rajesh, you execute the echo dollar path, man. So what you do? Hey, use up arrow mark key, man. Relocate that command again. See, you can use up arrow mark key or down arrow mark key to relocate that command and execute it. See, you can execute like this, or the down arrow mark key. When you are using up arrow mark key or down arrow mark key, you are actually navigating within the shell buffer content. It is like a pointer. So if you're using up arrow mark and down arrow mark key in your keyboard, right? So I'm using up arrow mark. See, I can locate what are all the commands which executed today, right? See, lsttr, see source, see so many commands executed, right? So all these commands you are able to navigate using up arrow mark or down arrow mark key. Oh, you can relocate any of the command and execute. You say, okay, fine. So that is what the history has been maintained. So when you exit from the shell or when you're out of the shell, all this output of this history content will be saved in dot bash underscore history. This is the file, sir, where all the commands, see, could see all this output, see, it has been written, see. just a few minutes back, right? See, you could see that I had created a hello.c. I compiled the program gcc hello.c, right? And I executed a program, right? See, gcc hello.c, all these things. Now, Rajesh, why we maintain this? Why we need the dot bash underscore history? That was the question. So the answer to this is that, okay, fine, sir. Today, what you did lot of work. Today, morning 6 o'clock to night, evening 5 o'clock, you worked nicely, completed, and at the end of the day, you exited from the terminal and you went out. Means you logged out. So what are all the commands which are there, sir, in the bash shell, sir? All those commands were copied into the history file. Sorry, to the dot bash underscore history file. Okay, fine. So tomorrow again you come back. See this, see all these files are dot bash underscore history, dot bash underscore logout, dot bash underscore profile, dot bash rc. All these files are pertaining to the root user itself. If you're creating a normal user, suppose you say, sorry, Rajesh, user add, I will create Rajesh. I'm creating one user account, PSSWD, passwd Rajesh. Passwd Rajesh, Red Hat, Red Hat. See, I have given a username as Rajesh, password as Red Hat. See, I will switch to the Rajesh user account. Rajesh is there. Does Rajesh also has the dot bash underscore logout, dot bash underscore dot bash profile? He doesn't have the dot bash history. Okay. But you see, you'll make out now. Say execute ls command, execute date command, execute who command. I exit out from the Rajesh. Again, I logged into the Rajesh. Again, I do ls funny. Now you could see dot bash history is getting created. So with this, we have proved, right? I exited one as soon as I exit from the user Rajesh, the dot bash underscore history file was created. When I open this file or when I do a cat of dot bash underscore history, see, I can see all the content what Rajesh has executed previously. Till here, are you clear, sir?
Yes, sir.
So
Yes, sir.
it means that actually that this file will get created once you exit out from the shell, and this is a permanent file, sir. It will not go off now. Now, but what is the use actually? Now we say that Rajesh has executed so many commands, he left for the day or he exited out. All the content of the history, it was written to the dot bash history of his home directory only, because each and every user, he had its own specific dot bash history file. Now tomorrow, as soon as Rajesh comes and logs in again, he tried to log in as a root as a Rajesh user account. What are all the content with the which was then the dot bash underscore history, right? That file that will be recopied to the buffer again tomorrow again. So that if Rajesh is executing any command, so instead of searching the path element variable, the shell will try to search in the history, or it will try to search, the shell will try to search in the buffer content. Is that command has already been executed? Yes, that command has already been executed. That command from load that command from the buffer memory and execute it. That is the use of it. It means that tomorrow once he comes back, how shell will do whatever the dot bash underscore history content is there, that will be copied to the shell buffer. And Rajesh, if he is executing any command, it will try to load the command from that buffer itself, if that command exists in that buffer, in that shell buffer. So that is how it will be very faster execution for any shell. If the entry of the command is there in the circular buffer, or as the entry is there in the hash table. Is it clear, sir? Guys, I hope that you got it, all the point, right? Yeah, I'm sorry, like we tangentially went somewhere else. We will come back to it because we started with the bash features explaining about this and explaining the history. But when I started explaining the history, I should explain all these things whatever I told you, right? Because you'll be able to understand now, right? Okay, guys. So I think we will stop the session now. It's already 1.5 hour session. So we will try to meet at 10 o'clock tonight.
Sure.
Okay, guys. So hope everyone got it right. Okay, sir, are you finding interesting?
Yes, sir.
Do you find really interesting? Okay.
Yeah. Whenever we learn commands, it's always interesting, right? Especially for hash tables, these content all are even we don't know. Even I don't know, especially. Just today only I got to know.
Yeah.
how this
Okay.
history maintained, all this.
Yeah. So that's what you will be learning a lot. You will enjoy learning many other things when it comes to networking, when it comes to LVM, when it comes to the user management, when it comes to scripting. Heavily, you will learn like anything. You will enjoy working on the scripting actually.
Yes, yes. Sure, right,
Okay.
definitely.
Okay, sir. Chalo. Start the session.
Yeah, yeah.